Okay, so we're identifying transformations on trig functions again, amplitude, period, and the equation of the midline all together now. So, the amplitude of a trig function is the coefficient all the way out front of it. This one has an amplitude of 6. This one, there is no number out front, or actually there is, it's an invisible 1. So for this one we would say the amplitude is 1. And this one, the coefficient out front is 0.5. That is our amplitude. Okay, period. I'm going to use capital T for period, as they often do in physics, is 2 pi divided by b. And b is the coefficient of x. It's inside the sine function. So the amplitude is a multiplier outside the sine, and b is a multiplier inside the sine right here. b is 1 in this case, which means our period is just 2 pi. Here b is 4, and so our period is 2 pi divided by 4, which cleans up to pi by 2. And in this one, b is 0.5, so the period is 2 pi divided by 0.5, and 2 divided by 0.5 comes out to 4. The midlines are 0 generally for a basic sine function, and if there's a number outside the sine, like this one is, then that is the equation of your midline. So for this one, the midline would be y equals 1. You know this is outside the sine because there are no parentheses around it. If they'd written this, then that would not be part of the midline. That would mean that we had a horizontal translation or a phase shift. But without those parentheses, that's our midline shift. This 8 is inside the sine function, therefore that is not the midline. We don't have a midline number in this one, or to be precise, our midline number is 0. And for this one, since there are no parentheses, that 0.5 tells us our midline. There we go. Which of the following functions contains a phase shift? Phase shifts happen when you have sine bx plus or minus c. So you're looking for a number that's inside the sine function, added or subtracted. Kind of like this one. This is the only one of these three which contains a phase shift. It's shifted 2 units to the right. Only 2 units, because technically we should be writing this sine, factor out the 4, and then you get x minus 2. That tells us that this wave is shifted 2 units right, or that it has a 2-unit phase delay. You can confirm that by graphing it. You'll see it isn't 8 units out of whack, it's only 2 units out of whack relative to plain old sine x.